Finding the vertex of a quadratic. So, first, the axis of symmetry is the line that splits a parabola into symmetrical pieces. So if the parabola is a function, then the axis will be a vertical line with an equation x equals something. So in this case, maybe something like x equals 3. It's wherever it crosses the x-axis. So this is an axis of symmetry. What that means is if there's a point over here, and it's 4 away from the axis, then there's a point at the same y-coordinate that's also 4 away from the axis. Here, this point is important. We'll get to that in a moment. These 2 points, the roots, will be the same distance away from the axis as well. So, the vertex is the point where the axis of symmetry meets the parabola. The parabola will have a slope of 0 at the vertex because that's where the parabola is turning around. If it's at the bottom, like this one, it's called a minimum. If it's at the top, then it would be called a maximum. The vertex, or axis of symmetry, gets calculated in different ways depending on what form you have. So from vertex form, you read off h comma k, just like in point slope form. From standard form, you either need to convert to vertex form or use the formula x equals negative b over 2a and substitute in for y. From root form, you'll either convert to standard or vertex form, or take the averages of the roots and substitute in for y. So, vertex form is the easiest. Here we have positive 5 and positive 8, which means that our formula is negative 5, comma 8 is the vertex of that. Please realize it's always switching the sign for the x-coordinate. For the other one, we have positive 1, because we're switching the sign, and negative 4, the y-coordinate does not change. So we'll say h is 1, k is negative 4. For standard form, we're going to either convert to vertex form or use negative b over 2a. This is part of the quadratic formula, negative b over 2a. b is 10, a is 1. So we'll say negative 10 over 2 times 1 is negative 10 over 2, or negative 5. So that's the x-coordinate. For the y-coordinate, we put in that x-coordinate to find out the y-coordinate. So we have 25 minus 20, minus 50 plus 5. That becomes negative 25 plus 5, which is negative 20. So our vertex is negative 5, comma negative 20. The axis of symmetry for this equation, well, we take a equals negative b over 2a. b is negative 15. a is 3. 15 over 6 is 5 halves. So x equals 5 halves is the equation for the axis of symmetry. For the vertex or the axis of symmetry, from root form, the fast way is to take the average of the roots. So here our roots are negative 2 and 20. Please don't say negative 2 comma 20 is the vertex. What we're going to do is we're going to average those. So negative 2 plus 20 over 2 is going to be our axis of symmetry, the x-coordinate of the vertex. 18 over 2 is 9. Now, for 9, we'll plug in 9 plus 2 and 9 minus 20. So this is 11 times negative 11. Negative 121 times 4 is negative 484. So our vertex, our final answer, is 9, comma negative 484. Zoom out pretty far on your calculator if you're looking for that. The range. The range is based off of the y-coordinate of the vertex. So what we'll do is we'll take our roots 3 and 7, average them. 3 plus 7 over 2 is 10 over 2 is 5. And then we say y equals 5 minus 3 times 5 minus 7 is 2 times negative 2 is negative 4. So our vertex is 5 comma negative 4. That y-coordinate is negative 4, and we're going to compare y to negative 4. Because a is 1, Because a is positive, we're going to say y is greater than or equal to -4. That's how we find vertex, axis of symmetry, and range.